Good evening, I'm Denise Bryan. I'm the health officer with District Health Department number 2. The irony is I'm supposed to welcome you all here, and that every one of us wishes we didn't have to be here to have the conversation on fluorinated chemicals. It's a situation that we've been having town hall meetings for over a year, and we have some progress that we want to report out, and the individual agencies also want to do updates, and we also want to have time to answer questions and address issues that you have. One of the things when I'm in situations that are complex and terrible situations, I always look for the helpers. Who are the people to have at the table to help solve the problem? And a year ago, I told the residents that made it in for those town hall meetings that I can't promise you a swift remedy, but I can promise you that we'll stay connected with conversations and transparency of the information. And I will advocate because we all deserve safe, quality, clean water. I have talked to many legislators, and I even have been in Washington, D.C. with Representative Kildee. And we have many legislators very supportive of the work here. We made a decision a year ago not to kick a can down the road for somebody else to deal with, but to start to look at data as to what happened with the Worksmith Air Force and the chemicals. So one of the handouts I had at the health department table this afternoon for the open house is the collaborative agencies, because the situation continues to evolve. And I've included on there, in the middle is the residents of Oscoda Township, because that's where we have the primary concern. I'm learning that Osable Township is here, worrying about the flume moving towards their residents. We have the different agencies here and the United States Air Force. But we also, I just want to point out that we get a lot of calls from veterans now who are hearing about Worksmith Air Force Base with a lot of questions. So we do have veterans as part of the equation here. We know there's the media that's playing a great role in getting information out. Because social media and the news is a number one way we can communicate. So they're a partner we want to include. We recognize that there's been studies with the fish, but there's more questions about different wildlife. And we know there's attorney and legal partners involved in this process as well. So today, I want to just let you know that you'll be hearing presentations from a variety of the agencies listed above. We'll do questions as well from the group. And, you know, we're just here to learn. And there's going to be people that are at different levels in this auditorium today. Some that are just hearing about it for the first time, and others that have been dealing with this since, you know, a year and a half ago in February when we did the advisory. So I think it's really important to hear from each agency with where they're at with this process. And we have first up Bob Delaney with the Environmental Quality Specialist.
All right. Well, all right. Okay. I'm Bob Delaney, and I'm the project manager for the state. Essentially, my job is to oversee the work of the Air Force, of the Department of Defense in the state of Michigan. And we work on, well, there's about 100, 200 sites in Michigan altogether from historical activities of DoD. So this is a site I've been working on now for 20 years, and for many of you, you've been here to several presentations, so you're going to see some of the same slides because we know there's going to be a lot of new people coming in as we found that the plumes are bigger and as more people have become informed. So we're going to cover a few of the same things that you've seen before to help the new people kind of understand what the issues are. So typically what my group does is we oversee whatever the Defense Department's doing. So the Defense Department usually does all the investigative work. They do the risk assessments, they design the remedies, they do all that kind of work. But on certain things, the grant that I work under, if they don't want to do something, then I have to go to my state office, my leadership, and ask for money to do the things that, if we get in a disagreement about something, I get money to help do investigations so that we can make sure they're doing what we think needs to be done. So tonight what I'm going to do is just update you on the progress with what we've found in the last several months since the last public meeting. And we've been drilling and sampling quite a few areas and new things to report to you all. I'll be mostly just the technical stuff. After this will come people talking about the various, what their agencies do and the various other issues. This is just the science. It may put you all to sleep, but I love this stuff, so you'll have to bear with me. All right, did you advance that, or did I? Okay. The first thing for those of you that aren't familiar with these chemicals, at the base what was mostly lost was AFFF, which is firefighting foam. But this stuff comes in all... Louder? Can you turn that up, or... Okay. Okay, is that better? Yes. Okay. I have plenty loud enough voice, but I like the mic. So anyway, these chemicals are everywhere in your environment. This room has these chemicals floating around. The treatment of the carpets will be these chemicals. A lot of your garments will have these chemicals in them. As you can see up here is a list of items that you have every day in your life. Let's see here. Thank you. Your computers have them in them. You're all familiar with nonstick Teflon pans. That's the same chemical that we're finding out here is associated with Teflon. There's in your wires and your cables in planes. There's a lot of uses in aeronautics, and I'll explain that in a minute. All kinds of in plants all over, anywhere where there's a lot of stress on a gasket or something like that, these chemicals can take that stress. They don't break down. So that's why you send it. Your phones, you all have it in your phones, and in your cars. It's in your cars. I think synthetic oils have a lot of this stuff in it. Next slide. Your paints, the stuff on the wall. You know how your kid can write with a crayon on the wall and you can wash it off. That's because of this stuff. And there's a lot of coatings like that. Your Gore-Tex, I know a lot of you guys love Gore-Tex just like I do. I have not given up my chemicals, even though these are not great for you. And firefighting foams, of course. Next slide. Okay, so at Wordsmith, the #1 release of these, there's a couple of ways they've been released, but the main way has been through firefighting foams, either practicing putting out fires, spills, or actual putting out plane fires. There's a KC-135 that went down, and they had to go put that out. So these things get into the environment that way. And Wordsmith is, as you'll see when we get to the plume, it's gotten everywhere. So before this, they used a foam or foams, but they were made out of proteins. And those proteins weren't very effective, and I'll have a slide to show you the difference between the old firefighting foams and these new firefighting foams that contaminated the water here. For a little bit of the techie out there, the carbon and fluorine bond is the strongest organic bond. And all that means is that there's a chain of carbons and then fluorines on each one of those carbons. And that bond is so strong that nothing in nature, other than a lava or something like that, nothing breaks those down. It's a very useful thing for we humans. Like I said, in aeronautics, those planes or spacecraft are going to go from really hot to really cold really fast. Well, most stuff can't handle that, so these show up in those. And then what that means, though, is because these things, nothing breaks them down in nature. Once they're out there permanently, just about. I mean, there's just not anything we've really found that breaks them down. So some of the chemicals will break down to a certain point, and then they stop. They will not break down. No bugs, none of the other stuff. And right now, the only thing we know of for sure is high-temperature thermal incineration will break them down. That's about it. Although there's a lot of work being done to find cheaper alternatives. Next slide. Okay, many of you have seen this slide before, but it illustrates, one of the important things is to help you realize that the Air Force wasn't using this foolishly, and this was something that was really critical to their mission, and the Navies and the Armies, and at regular airports. But anyway, in 1967, the U.S. Forestville fire was on an aircraft carrier, and the planes and the fuel caught on fire, and they couldn't put it out with the protein foams. It just kept burning and blowing up. And so in the end, 134 sailors died, 161 sailors were injured, and $500 million worth of damage was done. And the Navy realized they had to do something better than that. They couldn't stomach those kind of losses. Wanted to protect their soldiers. So they worked with 3M, and they came up with this AFFF firefighting foam. Now, to tell you the difference, how good this stuff is, what they're required to do is put out a fire in 1 minute. So this plane goes down, it's burning. You have 3 minutes before that fire penetrates the hull of that airplane. So 3 minutes and everybody's dead in that plane. So they figure it takes 2 minutes to drive out to the plane and set up, and 1 minute to get that fire out. And this stuff is the only stuff that'll do it. So as I say, if I'm on that plane, they better be using AFFF, and afterwards we'll figure out how to clean it up. But you want that stuff because it's the only thing that'll put out these kind of fires. And the firefighters want it too, because if you use the other stuff, the fire will pop back up at them, and firefighters can get killed if the stuff doesn't work right. So it's been very important to the Defense Department and your local fire departments and many other industries. Next slide. So one thing I wanted to bring up, and this is something we haven't talked to you about before, is that the language is changing. We've been saying PFCs for a long time. That means perfluoroalkyl chemicals. All right, you don't have to remember that. Because anyway, we're not going to be using that term anymore. The government and regulators had been using this, and everybody was actually using the term PFCs. But PFCs are those chemicals that leak out of your refrigerator, used to, and did the ozone. So they said, all right, they already got that acronym. We got to come up with another acronym. So it's moved to PFAS, PFAS or PFAS, PFAS, either way. So that you'll start hearing that term more and more, and it's been academia that's been leading that. But increasingly, like I went to speak at a conference, and you get whacked every time you say PFCs. You got to say PFASs. So it's now the term du jour, and so that's what we're using from now on. So if you hear that coming out of my mouth instead of PFCs, we'll continue to use PFCs up here, but PFAS is going to become more prevalent. You'll see it in probably media and more. So just so you remember that, we're changing language. All right, this is the base, and for scale, this is about 2 miles long, that runway. So that's the base. They didn't include the golf course for some reason. Next slide. Okay, so you've been getting a lot of you have been getting results back. Residents have been getting results back, and maybe your neighbor has some in it in their well, and you don't have much of any, or you've got a lot, and everybody else in the neighborhood's fine. Well, this is why that happens. Say up here at the Air Force Base where they use the AFFF, it starts right up here in the soils, and it gets down into groundwater, and then it just flows with the groundwater. And so this flow line where the contamination is flowing along here and ends up in your creeks or Van Etten Lake, or on the other side of Van Etten Lake, be that the case. But anyway, if your well happens to be shallow and in that flow line, you're going to get hit with the contamination. And your neighbor, who's a little deeper, they may not get hit at all. And that can reverse. In certain places, it'll be the person that's got deeper well that's impacted, and the shallower well isn't impacted. So that's why your results vary all over the place, even though you're right next door. And it's part of the reason why the health department advised to certain areas not to drink the water, because we couldn't tell where the plumes were in relation to people's wells. So we didn't know if, next month it was going to move up into somebody's well or not. So that's part of the issue. All right, next slide. Okay, what we wanted to do is, since the last public meeting, like I said, my group, we characterize the site. We go out and figure out where the contamination is, where it came from, where it's likely to go, who's likely to be impacted, what biota are going to be animals, vegetation, what's going to be impacted by this. That's what we do. So here's, since the last meeting, the blue wells were all the residents that we had sampled in the past before the last meeting. Since that meeting, we've sampled all these residential wells, all these residential wells down here as well, and down in here. And what we found is that the contamination, we'll show you a little bit in a minute, but up this way so far, we've not detected contamination above criteria, above the health advisory. And Chris will be speaking about the health advisory in a little bit. But that's what we've done with regard to those. Next slide. And here's what the plumes look like today as we know them. And one of the things you can't see is there's dashed lines all over here. Dashed lines mean we don't know where it ends. That's just as far as we've gotten so far. And one of the challenges has been and we're testing your wells, and we can say, okay, this well is contaminated, so we know the plume made it up here. But we don't know how deep your well is. We don't know how they constructed it. We don't know any of those kinds of things. So there's a lot of data and a lot of things we don't understand. The newest findings have been that the plume is now on the south side of the AuSable River. That we found that in our last efforts. We also found that there was a home here with PFAS contamination, PFC contamination above the 70 parts per trillion health advisory. That's a health advisory put out by the U.S. EPA, and it's a number that both the Air Force and we have used for determining risk at various homes. So anyway, these are the plumes as we know them today, and we'll keep discovering new plumes as we go. This is an ongoing question, because the Air Force didn't keep records. Oh, we sprayed it here, we dumped it here. That wasn't the kind of records that they typically kept for something like AFFF. In fact, in the past, it was considered totally safe. I mean, firefighters would have their kids playing in this stuff. It was thought to be inert with regard to our bodies and with regard to the environment, but the reality was it's not. It does have effects. Next slide. Okay, this is just to show, these were background wells. The state put in these wells years ago for other types of contaminants. So we went back there to see, this is out in the forest. So this is up gradient, all the water is flowing from this direction down this way and down this way. And so the water that's coming into these wells comes from up in here. And so those wells, if you could see the data, it's like 1, 2, 3 parts per trillion of PFASs total. And we're going to show you some, so those are the background locations. That's, if you, just anywhere you sample, you're going to see 1 or 2, 3 parts per trillion of these contaminants. Because they're literally the highest level of organic contamination in polar bears is this stuff. So this stuff is really all around the globe. You go to the middle of the Pacific and look at herring eggs, and they will have this stuff in it. It's everywhere. So there's no place you can go really where you're going to be exempt from running into these. So that gives us a challenge, because what came from the base and what's just out there. All right, next slide. So one of the ways that helps us understand where this stuff is and where it came from. Did it come from the base? Was it just something local, a small problem someplace? Where is it coming from? Well, one of the ways we can do is there's 19 of these chemicals out here that we've found, 19 or 20. And when you find firefighting foam, you see this chemical, perfluorohexane sulfonate, this chemical, PFOS, this is like Scotchgard, and PFOA, that's like Teflon. You see these three chemicals generally anywhere where there's firefighting foam. And so, go ahead to the next slide. So this shows you something about where the plumes are and which plumes we're concerned about. See, I showed you the background wells right here from the state's background wells. It's just water coming from the forest and from rain. And you can see all gray and that little bit of blue. Again, up here's another one, a very low contamination, gray and blue. But then you get down here to the heart of the worst places where they did the firefighting practice, and you'll see lots of PFOS there, lots of that PFOA, Teflon, and that hexane form. So you see that pattern right there. You don't see much of any of that gray stuff. All right, over on the other side of the base, again, you're seeing those three colors. Well, then when we move off base, across the lake, here we go, we see those colors. Now, as these move farther and farther away from the source, some of the chemicals get bound up. They don't go as far as the other ones. So you'll see changes in that, but you'll still see that pattern. So down here at next to the dam, you see that pattern. Down here along the Sable River, you see that pattern. And then when you go over to River Road near the high school, you again see that same pattern, but just a little ways to the east, you're back to background. So we're confident that all along here, we're just seeing background levels. So all these folks that have had their wells tested, we say this is what we see. We see very low levels, and we don't see stuff that looks like firefighting foam. So that's the kind of work that we're doing to try and understand. One of the things to realize, and I didn't mention this earlier, like I said, this was in so many chemicals and so many manufacturing processes, and like in your synthetic oils. Well, you could have this stuff dropped anywhere. And so as we move away from the site, we're likely to run into other problems. And how do you tell, is this from the base or is this from another problem? So up here we've got two wells, and those two wells, they have PFCs in them, but they don't look like the firefighting foams. They're low, they're higher than these background levels, but they're low. That could come from septic fields, that could come from fertilizers, that could come from some other source. So we need to be able to sort that out as we get farther and farther from the base. Next slide. This was just to show the work that our district staff has been doing. My work is focused in on whatever the Defense Department is working on. There are sites away from here, and like I said, we'd run into other sites as we move farther and farther away. Well, down at the high school, there were two fires, a forest fire and a garage fire where there was tires on fire. And so the fire department from the base came over and helped put the local fire department, they had a mutual aid agreement. So when this fire got to be getting to the point where the locals knew they couldn't contain it, they called in the Air Force, and the Air Force came over and put that foam down, or the caretakers at the time, whoever that was, came over here and put that fire out. So that's why we see two separate plumes down here. But those are not coming from the base. Okay, this up here at Colbath, we sampled this really just because it was so close to the base and the people asked us to sample it. So we went up and sampled, and sure enough, there's a plume up there. But we know it's not coming from the base. We're not sure where it's coming from. There was a fire up here where they used foams. We don't know if it's coming from there, or if it's coming from the west, or if it was something that happened in that neighborhood. But it's all very low contamination, low-level contamination. But it does have that firefighting foam signature. So we believe it was firefighting foam. Somehow it got out there. And then over here. So this is a lot of the work that they've done since the last meeting. And that's been done with state tax dollar money. The state has been doing that. Next slide. Then we know here in Michigan that when the glaciers were here, there were huge rivers. I mean, like rivers like the Mississippi flowing through here. And this AuSable River is actually just a minor, tiny river on top of what was a huge channel of material. Oops. Sorry. And then there was an earthquake and everything. Oh, okay. All right. So anyway, what happens in Michigan a lot is that a plume will come down to a river like this, and there'll be all these channels of all this gravel and sand that's down below, like the AuSable River. And instead of going into the river, what they'll do is they'll turn and start following the river. They won't actually go up into the river, they will follow the river. So that's what we were trying to find out, because if you look on an aerial photo, what you'll see is this channel right here actually continues way down here, whereas the outlet is right there for the river right now. Well, in historic times, or maybe prehistoric times, that river went way down here. So we don't know if it got into that channel and kept going or not. So that's one of the things we were checking. Excuse me. So I'll just show you. So my team went out with drilling contractors, and we drilled along here, and we drilled over along here, and we'll show you just one of the cross sections just to show you what's going on. You want to go ahead? No, thanks. All right, so this is, right here is the AuSable River. See that little thing there? And all this down in here is from rivers from glacial time. And then some floodings from Lake Huron too. But anyway, this is sands and gravels down here and down here. And then there's this funny thing right here where it looks like there was a valley cut right into the AuSable River, really sharp valley. So anyway, when we geologists look at this, we see all these things that I'm sure you guys don't see. But anyway, what we looked at, you can see these signatures again of the firefighting foams in the groundwater along the AuSable River. So it's not in the AuSable, it's following these river channels. We have one over on this side. Looks a little bit different in its characteristics as far as how much perfluorohexane sulfonate's in it. But then we see another totally different plume down in here. One we haven't seen this signature anywhere below, and it's in that funny cut of a valley. So now we're thinking 3 different plumes, 3 different source areas. This is on the south side of the AuSable River. This is on the north side. So we'll be looking to see if this stuff went further south and other things like that. But that's just a quick snapshot of what we do. Next slide. So what the state's decided to do is, people are calling in, they want to have their well sampled. Totally understandable. And we haven't had a good way of saying, well, no, you're not anywhere close to being in these plumes. We just go out and sample people's wells. And then if we run into another plume, we don't even know we're running into another plume. It's very difficult when we're just taking your wells and trying to figure out where things are. So what we decided to do is that we're taking some of the state's cleanup money, and we're going to do an investigation to see how far north that plume is. Because what we want to be able to do is say to people when they call in, yes, you're in the area of concern, or no, you are not in the area of concern. Right now, we can say we don't think you're in the area of concern, but we really can't say definitively. And that's never a great answer if you're worried about your well. And so that's what we'll be doing. This study will be going this summer. We'll be putting wells up in this area around Cedar Lake to try and understand what's going on there. Down here on the south side, where the AuSable is, just south of that, to see if we got stuff still following south. And then we want to know if the plumes from the base are actually going all the way under the AuSable and keeping going south. Because it looks like there's another one of those huge channels that I just talked about that used to go through here. So that could be pulling water further to the south, pulling those plumes to the south. So we'll be checking for that. So you can expect to have us out here, see us out here drilling this summer for these things. I think that's about it. Oh, one last thing. I know for the veterans that are here, we've talked in the past about the hydrant study. And I think most of you are probably familiar with that. What we did is we went onto the base, we said, okay, these chemicals, like I told you before, they never break down. Okay, so most chemicals, if you set them in an old water tank for a while, they'd break down, they'd adhere to the surf sides, they'd do something, and you wouldn't be able to tell what was in there in the past. But under the current situation, these chemicals don't break down. So we knew that if we could go out and find water that was trapped from the era when the base was operational, we could get an idea of maybe about how much people got exposed to. You know, we cannot give you a dose. And I'll have to understand that. I cannot say to any one of you, well, you took this much in, this was the levels that you consumed, and this is the levels that would be in your blood. I can't do any of that. All we can do as our technical team is say, yes, it looked like that they had drank water that was above the health advisory, or no, they didn't. So we did that with the hydrants. As a way to also check to see if what we were seeing makes sense, we're also running a model. And I mentioned that to you before, but what we have been able to do is go back through all the old pumping records of the base, how much they were pumping out for drinking water, how much they were pumping out for treatment, and we can model where the groundwater was flowing. So if I know that this little blue patch here of water all flowed into these two wells, and I know the approximate concentrations, and I know how much they were pumping, I can calculate an approximate concentration for this little plume. And again, with this plume, I know where these wells were drawing water from, and I can see what the concentrations are in those areas today. Not in the past, but today. What were those concentrations? And then I can just calculate, all right, if the plume was like this in the past, this is approximately how much was in the people's drinking water. Again, that's not going to be a definitive dose. It's just going to be a double check on what we're finding in the hydrants. Does this hydrant data make sense? Does this make sense? That kind of thing. And again, the question is it above the health advisory number? And then we kick that data over to the decision makers to decide what happens next with that information. Next. And that's it. Are we going to take questions now or wait till later?
Hi, I'm Sue Manenti. I work for the Michigan Department of Health and Human Services. I'm a health educator, and I work with Chris. A lot of you have talked to Chris. We're going to take just a couple of questions now for Bob, and we have a long question and answer session when we've gone through all the presentations. So I promise we'll answer, or try to answer, all of the questions that you have. We'll take the time to spend with you to do that. But if you have a question now specific to the presentation that Bob just gave, we'll take just a couple of those now if you have those.
We'll start here, I guess.
Yes, listening to your presentation, most of what you're describing is plumes that are underground. How extensive is the testing been for surface runoff and also for the AuSable River water as well? What's contained in the river at this time?
All right. The question is, we talked a lot about what's in the ground, and that's been a big issue with drinking water. But his question was, what about surface water? And we've mapped the impacts to the surface water all the way from Van Etten Lake all the way up to Clark's Marsh and AuSable River and Van Etten Creek. And it shows impact. The marshes are impacted more than any place else in the world, maybe. They're really, really heavily impacted. The river isn't showing as much contamination as I thought would be, and so it may be those plumes are just not going into the river, they're following the river. So, but the little streams that come off those down there along the Asaba River, some of those are very contaminated. Van Etten Creek is moderately contaminated. It's not really, really high for the most part. And then the average contamination in Van Etten Lake is not very high, but there are some local spots that it is higher where plume might be coming out specifically. So yeah, we're looking at that, and we're going to be increasing our sampling of the surface water to monitor the effects of changes in treatment and get a better handle on seasonal variations and things like that. So we'll be doing more of that. We have so much data and so much information that we just didn't cover that in this presentation. Any other question on that? Okay, I saw two hands over here.
Can you tell us how fast those plumes are moving?
The question was, how fast are the plumes moving? So this is going to be a rough estimate because each contaminant moves at a different speed. All right, some contaminants don't move at all. You put them in the ground, they stick to something and they never move. Others, like chlorine, like when you drop salt on the road, that moves as fast as the groundwater moves. Now, some of these chemicals, I think, move almost as fast as groundwater. On the base, the groundwater moves, I think it's 1 to 2 feet a day, approximately. So 1 to 2 feet. You get into other areas, it's going to be slower, but on the base, the water moves really, really. In our world, that's really fast movement. So, you were next back there.
I live in Hull Island, and I haven't seen any testing there. I was wondering what if we did any testing there. I have city water, where I have a well that I use for watering grass, garden, food products and all that.
Right.
Second thing, I've got Admiral gas station on 23 behind us that I think was leaking this year. Last year, they were testing for that. And just north of town, a little bit half-mile north of that, was a dry cleaning facility that years ago was leaking dry cleaning materials. Is it possible those plumes also are blending together? Or is it there? I don't know if they're cleaned up.
I don't know. We'll have to talk to you afterwards on those two plumes. We have a district person here who might be familiar with those. Typically, though, it's all the same groundwater. So if it was dropped into the same place that the PFCs were moving, I'm sorry. His question was twofold. There's a couple gas stations and a dry cleaner to the north of here that have had leaks, and he was wondering if that had commingled with the PFC plumes, and it has. We don't. If it's in the same area, it's commingled. And then your first question was.
I've got.
Right. What was the name of that island? Is that
Hull Island? Just
here in the?
Between the golf course and here.
Okay. Yeah, Hull Island. That's it. Yes, we've gone through the neighborhood looking for wells, and we've intended to sample people's wells. And so if you've got a well in there, you can come see me or my consultant, Dale, over here, and just give us your name, and if you want your well sampled, we'll sample it, because we want to know what's going on in that particular area specifically. So. Okay, over here.
My question is probably the same for everybody sitting here. These plumes and how fast they're moving, how fast is it depreciating the values of our properties?
Well, I'm a geologist, so we'll have to pass on that one for the moment.
Get it out there.
Yep. Yeah, I'm not ducking it, but I couldn't tell you a squat about that. Sorry. I think over here was next. Mm-hmm. Yep. Mm-hmm.
Kmart's are draining there, parking lot, into a basin.
Catch basin. Mm-hmm.
And I don't know if this is safe, and I don't know how whether the contaminate the potatoes catching up to me, but I'd like to have somebody check my water. I've had it since 1983, my water.
Okay.
And that was good.
Okay. What, you had it sampled when?
1993.
Yeah, these chemicals weren't analyzed in those days.
Well, I know, but
Right.
there's nothing there then, there's not, no need to be, this stuff like that now.
Oh, yeah. Well, this stuff is totally different. This stuff is farther along. And anyway, if you could talk to Dale, why don't you stand up, Dale, so they can see. If you have questions about your well getting sampled or something like that, you can talk to Dale or Chris, and we'll talk to you. You want to move on and let somebody else?
Just real quickly, if you pull back the map from where you were showing it south and east of the river, and you had mentioned that Colbath Road was really no contamination, south and east, the same color. So are you saying essentially that what we found south and east of the river is real contamination also?
Well, so far what we have, but those wells are, 500 feet apart, so I wouldn't guarantee anything with what we found so far. The highest we found has been about 200 parts per trillion, or a little over that, in one of the wells, which is relatively high, but it wasn't PFOA and PFOS. So it's a contaminant. We're concerned about it, but it's not one of the big ones.
We'll take one more.
The Air Force ain't really checking for more contaminants than just one here and one there when it comes to flowers.
Oh, well, you can ask the Air Force. They're analyzing for all the same chemicals we are. They're talking about PFOA and PFOS because there's a health advisory number, and so that's what they focus on. But
They're also antifreeze, de-icing the flame, jet fuel.
oh, that was
all that stuff.
for the last let's see, since 1980, we've been talking about that stuff. And we're actually getting to the point where I was thinking, well, we're getting over the hump. We don't have that many sites to finish up when this PFC thing came along. And the PFC thing dwarfs anything that they had in the past as far as size.
What my worry is they only check for one thing. Why don't we get the samples and check for all the chemicals they use for over the years? Why is it only one chemical at a time, just when we have a problem with it?
Oh, well, I mean, we force them to characterize all those other chemicals. Even today we were telling them they got to go after this other chemical that's new, that nobody was looking for the last 30 years. So even today we're saying, hey, another chemical you guys got to look for. So they have been out characterizing all those other chemicals, and the suites of chemicals that we sample for might be 200 different chemicals or 300 different chemicals, depending on where you're at. But as new ones come along, we never sampled for any of these new ones. So these new ones are way beyond anything we ever found before. There's no sense looking more for those other ones because we already looked everywhere for those.
Well, at least if they did that, they'd have a category of what they found. Even if they didn't know the PFAS was bad for you, at least 20 years ago when they left, if they started testing, they knew what was going on.
Yeah, they didn't have a test period until like 2000. Well, 2000 was about the year when they really first tests were done. University of Oregon and some other people were out here actually developing the methods. So there was no way of sampling for it. Nobody had any idea. We knew there was firefighting foams out here, but we didn't sample for the right things because we didn't know what to sample for. And it did not exist. There was no lab that could even do it at the time. I guess
All right, thank you, Bob.